In this video, we're going to look at what neutralization reactions are and how to write and balance them. So, neutralization reactions are reactions that are between strong or weak acids and a strong base. They are going to produce a salt and water. And remember, in chemistry, when we are talking about a salt, we are talking about an ionic compound that contains a cation other than a hydrogen ion and an anion other than hydroxide. So it's basically an ionic compound that is not an acid or a base. So while sodium chloride is an example of salt, it is not our definition of salt when it comes to chemistry. And this salt is produced from the cation of the base and the anion of the acid. Let's look at a few examples to see what this looks like. In our first example, it's going to ask us to write the balanced reaction between aluminum hydroxide and hydrochloric acid. So we can start by just writing down our two reactants there. Aluminum hydroxide plus HCl. This is going to give us our products. Now, our products are going to be a salt and water. So we know that water is going to be one of our products. And our salt is made from the cation of the base and the anion of our acid. And it's a salt, which means it's an ionic compound. So we have to look at charges before we can correctly write that out. So up here, I'm just going to write the charges for it. Aluminum has a +3 charge. Chloride has a -1 charge. And so the formula for that would be AlCl3. Once we have the correct formula, we can write that as our other product. So plus AlCl3. Now that we have our products written out correctly, we need to go back and balance them. We should start with the cation anion in our salt, and then we'll balance the hydrogen and oxygens from the water later. So to begin with, we have 3 chloride on our product side, so we need to get 3 on the reactant side. So if I put a 3 in front of hydrochloric acid, that will balance that out. We have 1 aluminum on both sides, so we're good there. So let's look at hydrogens next. We have 3 hydrogens in hydrochloric acid. We have 3 hydrogens in aluminum hydroxide, so that gives us a total of 6 hydrogens here. So if we put a 3 in front of the water, that'll give us 6 hydrogens on that side. That also gives us 3 oxygen. And over here we have 3 oxygen as well. Since we have a subscript of 3 outside of the hydroxide, that gives us 3 oxygen. So that is now a balanced reaction. We have aluminum hydroxide, our base, reacting with hydrochloric acid, and it produces water and the salt of aluminum chloride. Let's look at one more reaction here, and we're going to write the balanced reaction between nitric acid and barium hydroxide. So we'll start by writing our reactants, HNO3 plus barium hydroxide. And again, we're going to get water as one of our products, and then we'll get our salt as our other one. So it's going to be between barium, that's our cation, and the nitrate. And so over here, I will write our charges. So barium has a charge of 2+. Nitrate is one of our polyatomic ions, and it has a -1 charge. So that means that we're going to need 2 nitrates for every 1 barium. So we need to put our nitrate in parentheses with a 2 on the outside. So I'll add that as a product. Okay. So again, I'm going to start with balancing the substances in my salt over here. So I'll start with the nitrates. I have 2 nitrates on this side, and I have 1 on my reactant side in the nitric acid. So I can put a 2 in front of HNO3, and that will give me 2 nitrates on this side. Now, since the nitrate polyatomic ion is intact on both sides of the equation, you can treat it as a single unit and balance it like that. Okay, so now for barium. I have 1 barium on my product side. I have 1 barium on my reactant side. So now we'll look at water. Okay, so for hydrogens and barium hydroxide, I have 2 hydrogens here. From nitric acid, I have 2 hydrogens there. So total gives me 4 hydrogen. So if I put a 2 in front of the water, that will give me 4 hydrogen. That also gives me 2 oxygen over here. And I have 2 oxygen from the barium hydroxide. So it is balanced as it's written there. Okay, so that just goes through a fairly simple explanation of how to write and balance neutralization reactions between an acid and a strong base.